All right, today we are pulling back the curtain on the hidden conversations that are happening inside your favorite apps all the time. We're going to explore 5 completely different ways that software components talk to each other, a process that tech folks call inter-process communication. I mean, have you ever really stopped to think about how your apps actually work? It feels seamless, almost like magic, right? But underneath that smooth surface, there is a constant, complex chatter going on. And that's because modern software isn't built like one giant single block of code anymore. Nope. It's more like a highly specialized team of smaller, independent programs or services. And just like any team, if they're going to get anything done, they absolutely have to communicate with each other. So that leads us right to the software communication puzzle. How in the world do you get all these different pieces, maybe even written in different programming languages, sometimes running on totally different computers, to coordinate perfectly? Well, let's solve it together. You know, the best way to get your head around these different methods is to think of them as specialized messengers. I mean, you wouldn't hire a town crier to deliver a top secret spy message, right? Of course not. It's the exact same idea in software. You have to hire the right messenger for the job. First up is our most direct, our most local messenger. This one never even leaves the building. It operates right there inside a single machine, connecting programs that are working side by side. Let's meet STIO, which stands for Standard Input and Output. Think of it like a super trusted personal assistant. It's all about fast, secure, and totally private chats between processes running on the very same computer. And how it works is beautifully simple. A main program, the client, starts up a little helper program, the server. It sends instructions to the server's inbox, that's its standard input, and then it just waits to get the results back from its outbox, its standard output. It's really just a direct, private conversation. Now, the huge advantage here, zero network overhead. Since this conversation never touches the network, it is lightning fast. We're talking the fastest possible way for something like a command line tool to talk to a local script securely and instantly. Okay, so that's local communication covered. But what about when you need to send a continuous stream of information from a server all the way across the internet to your web browser? Well, that is a completely different kind of challenge. For this job, we've got a showdown between 2 really popular messengers. Now, both of them are designed to push data from a server to a client, but as you'll see, they go about it in slightly different ways. First up, we've got SSE, or Server Sent Events. This is our town crier. It just opens up a direct line to the town square, that's your browser, and it just shouts out updates as they happen. It's perfect for things like notifications or live status updates. And a cool little feature is that your browser is smart enough to automatically reconnect if the line ever drops. On the other side of the ring, you have streamable HTTP. This is more like a piece-by-piece delivery service. Instead of waiting for the entire package to be ready, it sends you little chunks as soon as they're available. And I guarantee you've seen this. If you've ever watched ChatGPT type out a response word by word, you've seen streamable HTTP in action. It is the backbone of the entire modern generative AI experience online. Okay, let's shift gears now. We're moving away from talking to browsers and diving into the heavy-duty internal plumbing of really big applications. This is the high-speed backbone that connects all the different services behind the scenes. And here we have gRPC. I love this analogy. Think of it like one of those old-school, high-security, high-speed pneumatic tube systems you'd see inside a massive corporate building. It's built to shuttle messages between all the internal departments, or, in our case, microservices, with incredible speed and reliability. So, what's its secret? Where does gRPC get all this speed? Well, it all comes down to its data format. As you can see, it uses a compact binary format called protobuf, not the text-based JSON you see in most web APIs. And because it's binary, the messages are way smaller and way faster for computers to process, which makes all the difference when performance is critical. Next up is probably our most flexible messenger, ZeroMQ. Now, this isn't like a central post office at all. It's more like a freelance career network. It's a really powerful library that lets all your different programs create their own messaging systems without ever needing a central server or a broker to manage things. You could say ZeroMQ gives your software's communication sockets superpowers. Seriously, it handles all the messy little details for you, like reconnecting if a connection drops or queuing up messages. This lets developers build these incredibly complex and resilient systems, like a distributed mesh of agents, without having to worry about one single point of failure bringing the whole thing down. Okay, whew. We've met our 5 specialized messengers. We've seen what they're good at. So how do you put it all together? How do you actually decide which one to use for your project? Because that's the natural question, right? After seeing all these different options, you have to be thinking, okay, so which one is actually the best one? And the crucial point, the main takeaway from all of this is there isn't one. It always depends on the job. Each one of these messengers has a unique skill set, and the secret to really good software design is hiring the right messenger for the specific task at hand. This chart here really brings it all together. Let's do a super quick recap. If you need blazing fast local communication, you hire STDIO. For shouting out notifications to a browser, SSC is your town crier. For that high-speed internal backbone, you build it with gRPC. For a flexible decentralized network, you call on the 0MQ courier service. And for streaming those AI responses to the web, streamable HTTP is your go-to. You know, when you see them all laid out like this, you can really see how they all fit together into a bigger picture. And that leads me to one final thought. The real power isn't just in choosing one of these, but in knowing how to combine them. So, how would you do it? How would you build a bridge to connect the super fast local world of SDIO with the web streaming world of SSE? Something to think about.